Hello again, and welcome to another discussion in the course Mathematics in the Modern World. So, we are now in Mathematics of Finance, and after the simple interest, the next topic is compound interest. So, here we have the formula for the compound amount. Okay, so the compound amount formula is A equal to P times 1 plus R divided by N, all raised to N times T, where A here is the amount, is the compound amount, P here is the amount of money deposited, R is the annual interest rate, N is the number of compounding periods per year, and T is the number of years. So, so here we are asked to calculate the compound amount when $10,000 is deposited in an account earning 8% interest compounded semi-annually for 4 years. So our time here, right, our time is 4. So first we need to, okay, so we need to recall our formula. We will recall our formula here. So our formula for the compound amount A, this is equal to uh, P, the principal amount, and 1 plus R divided by N and N times T. Okay, so we need to collect the given numbers or the knowns, right? So solution, our P here is $10,000. Okay, our rate here, or R, is 8%. Of course, 8%, we divide it by 100 to get the number 0.08. Our N here, right? Our N is how many times? How many times the rate is applied, right? So according here, semi-annually. So semi-annually means uh, every half of the year, right? So that means that we divide a year by 2. So our N here is equal to 2, right? And our time here is 4 years, so that is just 4. So if you do the calculations, the given numbers, so A is 10,000, multiply it by 1 plus 0.08, we divide it by 2, and 2 times 4. Okay, so you do the calculations. You should use your calculator here. This is a bit tedious. So 1 plus 0.04 raised to 8. Okay, after simplification, you will get 13,685.69. So the compounded amount is $13,685.69. Okay, so what does this mean? Okay, so actually the compounded amount is way bigger. Okay, this is way bigger if you use the simple interest. So here this is called the simple compound interest. Okay, so I hope that is clear. You can read your text, the reference text for this one. So we don't have enough time, so I need to fast track this one. Okay, so it means that if you lend the money or deposit the money of $10,000 and the annual rate is 0.08, and okay, and then the interest rate, this is compounded semi-annually, that is N is equal to 2, and our time is 4 years, then you will get 13,685 and 69 cents in dollars. Okay, so that is the compounded amount. Is we do the future value. Okay, so the future value is the same as the compounded or compound amount. So that is the same. So to solve this one, First, we need our P. Our P is 5,000. Our interest rate is 9%, and 9% is the same as 0.09, and that is compounded daily. Okay, so it means that the rate is applied every year, every day, I mean. So that will be 360, and for our time t is 3 years. So our amount A here is given as 5,000. Multiply it by 1 plus the rate, which is 0.09, and the number of uh, how many times is it compounded in a year, that is 360, and then 360 multiply it by 3. So after simplification, you will get 5,000, 1 plus 0.00025, and raise it to 1080. And after that, we will get the number 6,549 and 60 cents. So the future value is 6,549 dollars and 60 cents. Okay, so you just use the formula. I mean. Next, we go to how much interest is earned in 2 years on 4,000 deposited in an account, paying 6% interest compounded quarterly. So quarterly, that means our N here is equal to 4. Right? So first, we need to collect the knowns. So our P here is 4,000. Our rate here is 6%. 6% we divide it by 100, and we will get 0.06, and our n here, right? Our n. So according to the problem, it is compounded quarterly, so our n here is 4, and our time here is in years is 2. So according again to the formula, that is P times 1 plus R over N. We divide it by, we raise it to N times T. So you will get 4,000 times 1 plus or R, which is 0.06. We divide it by 4, and 4 times 2. So after simplification, we'll get 4,000 times 1 plus 0.0015 raised to 8, and you will get 4,505 and 97 cents. So the interest earned is $4,505.97. Okay, so I hope that is clear. And here, next is uh, you need to know the present value formula. Okay, so the present value formula is like how much money should you invest to get something. Okay, so here we have the formula, the present value formula. This is given by a somewhat complicated uh, algebraic expression or algebraic equation. So P here is equal to A divided by 1 plus R divided by N, all raised to N times T. Actually, this formula here came from our A, right? Our A is P times 1 plus R over N raised to N times T. So if you do a bit of algebra, you'll get that our P here is A divided by 1 plus R over N raised to N times T. Okay? So we are interested with P, or the initial amount. So what is the initial amount to get something? So here P is the original principal invested, A is the compound amount, R is the annual interest rate, N is the number of compounding periods per year, and T is the number of years. The present value of an investment is the original principal invested, or the value of the investment before it earns any interest. Therefore, it is the principal P in the compound. It is the principal P in the compound amount formula. So present value is used to determine how much money must be invested today in order for an investment to have a specific value at a future date. So say you are interested to a money, right? And then you ask yourself, how much should I invest today to get that money? Okay, with the following conditions. What are the R and what are the compounding number per year and how long? Okay, so here we have an example. How much money should be invested in an account that earns 8% interest compounded quarterly in order to have 30,000 in 50 years? Okay, so that is somehow 50 years. Sorry, it is in 5 years. So again, our formula for P is A divided by 1 plus uh, R divided by N raised to P. So that is our solution. Our P here is missing, but we want to get the compound amount, uh, 30,000. Okay, and then the rate is 8%, so that is the same as 0.08, and it is compounded quarterly, so and here is 4, and the time here is 5 years. So from this given, we calculate our P. So this is 30,000, right, divided by 1 plus our rate, which is 0.08. We divide it by our compounding, numbers of compounding in a year, and then 5 times 4, which is 420. Now, after doing some acrobatics in algebra, okay, you can do this one with your calculator. You will get the number 20,189.14. So if you want to get an amount of 30,000, right, for 8% interest rate, and the compounding number is 4, with the length of in years is 5, you need to invest today $20,189.14. So we conclude that $20,189.14 must be invested today, or must be invested to get the target amount A equal to $30,000. So you need to invest 20,000 plus dollars to get $30,000 in 5 years. So that is the end of the slide, and thank you for listening, and see you next time.